Thanks everyone for coming today. Hope you like the keynote speech. So we're in a HackerY tent in case you need to reference this throughout the conference. Our first presentation today will be on the new things from Parse. So really excited to present the Parse team here, and they're going to come up and speak about all the new things they're speaking to.
Hey folks, welcome to F8. I'm James, one of the co-founders of Parse. I'm super excited to talk about all the product launches that are happening today. Each of these have been handcrafted to make the developers' lives easier. So there's a lot to cover. In addition to the new IoT SDKs, we have Cloud Code webhooks, Parse Explorer, enhanced sessions. Francie will come up and talk about the IoT SDKs, and then Andrew will come up and finish off talking about our new Parse and React bindings. So ever since we launched Cloud Code, developers have been writing little bits of JavaScript to do things as simple as validations to more complicated things as like complicated game management systems. But one of the most requested features from developers is the ability to write Cloud Code in any language or any framework on their servers. Well, it's possible today with Cloud Code webhooks. Let's see how this works. So first thing, you have a Parse app, and then you get your own server running. Maybe that's on AWS, maybe that's a Rails server on Heroku. What you can do now is specify that on a before save, it'll hit a URL on your server. This will send over a JSON payload with object data. And then you can validate that however you want. Maybe you want to save that data, you want to back it up. Maybe you have some offline analytics or processing that you need to do for your app. What happens next is that you can send back a response in JSON. And if you've used Cloud Code triggers before, this looks pretty similar. You can pass back success true, or you can pass back an error, in which case the object is actually not saved. So today we support with Cloud Code webhooks before and after saves, before and after deletes, and also cloud functions. This means that you can specify a custom cloud function that now ties into your server logic. You can find this under the core dashboard in the webhook section. So you can specify for which class particular triggers that will hit your webhooks, see how the webhooks are actually responding, or specify custom functions. So the possibilities here are really endless. You can back up data. You can basically work with existing or new systems that you want to now start integrating into your Parse backend. So we hope with Cloud Code webhooks, you'll be able to use Parse with the servers that you love. Next up is Parse Explorer. So your Parse app generates a lot of API traffic. Maybe that's tens of thousands of requests, hundreds of thousands, maybe millions. Part of the daily grind is that you're debugging these requests. You want to really understand how your app is performing. Maybe you're trying to figure out how to fix a particular bug. But debugging your app can be hard right now. Before today, we gave you very specialized views into your data, whether that's audience data or crash reporting. It's kind of like pre-aggregated data. But one of the biggest requests here is folks want to be able to ask any kind of question, any kind of query. With the Parse Explorer, this is now possible. You can actually make a table, a time series, or get raw data using a GUI-like, MySQL-like interface. Even non-technical folks can go in and query arbitrary data in their API requests. Let's take an example. Let's say that you want to see how your app is performing. This is what a table looks like. If you're familiar with GUI interfaces into MySQL, this should look relatively familiar. But basically, you can build up a query bit by bit. let's say you want to find out which API requests are slow. What you can do is define a data source and a range. So in this case, we're looking at our API request events. And then we specify a date range, let's say a day. Next, you want to see what kind of columns you're interested in. So maybe you want to aggregate by the average latency. Then you can group this by request type, the class that the query is coming into, and also the Parse SDK that's making this particular request. So if you're familiar with MySQL, this is very straightforward. And then you sort the results by latency descending. So now let's take a look at the table. So we can see basically the request types on the left-hand side and the average latency. In this case, it looks OK. And you can see how you can dive deep into understanding how your app is performing. Note that latency is a new piece of data that we're now exposing exclusively through the Parse Explorer. Another question you may have is just which installations are making the most API requests. Well, this is easy too. All you have to do is aggregate by count and then group by installation ID. This will get you the number of requests that are made by each installation. So as you can see, this top one for this time period is making the most requests. Next up is time series. So this is great when you want to be able to, at a glance, see a lot of data at once and be able to make decisions based on that. Let's say that you want to see the adoption for different versions of your application. You push out a new version. You want to see if you want to drop features in version 1.0. What you do here is very similar. You can aggregate over the count of an installation ID, and then group by the time and also the app build version. So each of these lines represents traffic going to a particular version of your app. The red one is just the aggregate of all of them. So that's your total API traffic. The blue line here represents 2.0. And then 1.0, between 1.0 and 2.0 is all the other lines. So as you can see, most of your requests are going to 2.0, coming from version 2.0 of your application. So now you can know whether you can cut features based on the version. This is results that you can get very easily within just a few seconds and understand very clearly how the users are using your application and how the adoption of different versions are going. Finally, you get raw view data as well. So this is basically like a stream. You get JSON log lines, basically, for each of the events that are coming in. This is really good if you're, say, trying to debug a particular user's problem. Let's say you know that in this particular installation ID, you're getting a lot of complaints about it, or you're simply debugging it. You can filter results by installation ID, and now you see all the API requests that are coming into your app. So as you can see, I've really just scratched the surface. There's a lot that you can do with the Parse Explorer, and I encourage you guys to go check it out. We're slowly rolling this out to developers today, so watch out for it in the Analytics tab. Now let's shift gears a little bit. Today we're also launching enhanced sessions. In today's society, we're living in an explosion of devices. There's estimated more mobile phones in the world than people. And this is not including tablets and other kinds of devices, like IoT devices. And all of these devices are now holding much more data about you and also holding sessions to sensitive information and services. It's really important that you secure your application. For example, if you use Gmail or Facebook, you get an interface similar to this. You can see which devices you're logged in with, and you can log them out if, for example, you lost your iPhone, or if you know your iPad got stolen. Using enhanced sessions, this interface is now possible for your Parse app. You can build this for your users. So what are the new features? We now have separate sessions for each device. These sessions can also have less privileges. They can be restricted. And sessions can now auto-expire. Note, you can keep using classic sessions in your current Parse apps, but we provide a smooth migration path to the new enhanced sessions. And we highly recommend looking at that and migrating if possible. Let's dive in a little bit. This is how classic sessions look like. You have sessions per user. So device 1 and device 2 had the same session. Very simply, the new world, we have sessions, a unique session for each device. And these sessions are fully formed Parse objects on the back end. So you can actually see these sessions in the data browser and manage them that way, or through our APIs. From a user's perspective, they just see a session for each of their devices, whether they're on an Android tablet, or on their Mac, or on their iPhone. As I said, sessions are pretty much just like Parse objects, so they function similar to how installations and users work. They're basically a subclass with some special fields. And some of these fields provide very useful information for you to secure your app. Created with lets you know how the session was created. Was it created through a login, or a sign-up, or something else? Session token is the token for that session. Expires at lets you know when the session is going to expire. And we have a couple pointers, user and to also installation ID, to let you know the context of that session, who owns that session. And then there's a Boolean unrestricted. And I'll talk about restricted in a moment. So the actual API, taking Android as an example, is very simple. This is now available in all the SDKs that we offer. You can actually save data to this session just like a Parse object. But do note that when the user logs out, the session is destroyed, as expected. So this is good for ephemeral information, maybe like a shopping cart. But if you want more permanent information, you probably want that on the installation or the user. And of course, you can get the session for current installation and various other API calls. But the good news is that if you're using user login and sign up as normal, you usually don't have to even touch the session APIs on the client. The SDKs do all the hard work. They will manage a session for you, just like we did before. So let's talk about restricted sessions. Restricted sessions are really good for clients that are either less secure, or if you know that the client is not always on the user's body or within the user's grasp. Let's say that you're making a fleet management trackers that go into trucks that go around the country. Someone's managing all those from a central base. Now, if one of those trackers gets compromised, you wouldn't want that tracker to be able to, say, update user information or change the password. This is not possible using restricted sessions. So what you can do is have the main session create a restricted session for all of these trackers, separate session for each one. Then this restricted session cannot update user role or sessions, and they can only see other restricted sessions. They can have access to data in your other custom classes. So again, in many IoT instances, you may want to use restricted sessions. And Francie will delve a little bit more into that when we talk about IoT scenarios. You also get session expiration, and you can configure this to expire in 1 year or never expire, and that's configurable via the dashboard. Okay, so this is all great. Let's say you have an app out there today. How do you take advantage of these new session features? So you're in control. We are not sunsetting classic sessions, so old apps, existing apps, can function as normal. But there is a migration process if you want to use new sessions. And all new apps created today will also default to using the new enhanced sessions. Let's take a quick look at how we migrate. What you want to do is update the SDK on your current application and call this new function called enable revocable session. What this does is it takes the old session, it detects whether there's an old session on your client, and exchanges that for a new session from the Parse backend. Then you need to update your code to receive a new error, a new possible error called invalid session error. In those cases, you want probably a global handler to log out the user, reset the information in your app. And then you release your app and wait for adoption. Maybe you want 80 or 90% adoption for your app before flipping the switch. That's really up to you to decide what's best for your user base. Once you flip the switch on the dashboard, it will force all of your apps to use new sessions. So all the folks who have not upgraded will get kicked out and logged out. So this ensures that all your apps are going to be using new sessions. There won't be other old session tokens floating around. So there's a lot here. And I really encourage you guys to go look in our documentation. We have a tutorial to talk about the migration guide. If you have an existing app, I highly encourage you guys to look at whether new session you can take advantage of enhanced sessions. So now I want to invite Francie on stage to talk about our new embedded SDKs for IoT scenarios.
Thank you, James. Hello, folks. My name is Francie Penov. I'm a software engineer at Facebook. 2 years ago, James was talking at F8 stage, and he was talking about how easy it is to use Parse to build applications for mobile phones, desktop, web, and he mentioned connected toaster. Everybody was thinking that he was joking. Well, guess what? Analysts' prediction that by year 2020, the IoT devices, the connected devices, are going to reach about 27 billion. Compare that to the mobile devices, which are predicted to be about 8 billion, 7, 8 billion, and then fixed internet is going to stay around 1 billion. So a lot of those devices are going to be connected toasters. What are the specs for a simple connected toaster? It's going to have ARM CPU, Cortex-M4 single core, running at maybe 80, 100 megahertz. It's going to have 256 kilobytes of memory and maybe 1 or 2 megabytes of permanent storage flash memory. Imagine you had to build an application for a device like that. Well, today people are already building applications for connected device like that, and they're using the Parse REST API. The Parse REST API makes it really easy to save and load objects in the cloud, to do object queries. However, it doesn't make it really easy to maintain the identity, whether on the device identity or the user identity. And it also doesn't allow really easy to use object security. And of course, you cannot receive Parse notifications with the REST API. To solve this, we're offering a set of 2 new SDKs, Embedded C SDK and Arduino SDK, and we're also going to offer a partner developer here that anybody can use to port our SDK to their platform. What is the Embedded SDK? The Embedded SDK offers several features that you can find in the REST API. Those are the maintenance of the installation and the session. It allows you to receive push notifications, and of course, it isolates you from the network stack. You don't have to deal with HTTP or sockets. Compared to the phone SDK, though, we design it to be low overhead because of the devices that it's going to be running on. And because of that, it doesn't support fully objects, and it doesn't support push channels. We are going to offer 2 flavors of the Embedded C SDK. One of them is going to support Linux operating systems, and the other one is going to support a real-time operating system like FreeRTOS. So I mentioned that the new SDK is going to maintain for you the installation and the session. And James talked about restricted sessions. We've designed the Embedded C SDK to use primarily restricted sessions because most of those connected devices are not going to offer rich UX for the users. And so we are not offering login. You could use the unrestricted sessions, but because those devices don't offer the same level of physical security as phones and laptops, we wouldn't recommend this. So the heart of the new SDK is the Parse client. The Parse client is a simple handle that keeps the state of your application. You obtain a Parse client by calling parse initialize and passing the application ID and the client key. You can set the installation ID if you want to associate that device with specific installation that you already have, but you don't have to call. will create one for you if you don't have one. Same goes for the session token. You can set session token if you want the device to act on the behalf of a particular user, but you don't have to. If you don't have session token, the device is going to work in unauthenticated mode. What about saving an object? Saving an object is really simple. As you can see, it's very thin wrapper around the REST API, and we consciously choose this to make it work on small devices. You just provide the JSON object and the method and the path to your class. The push service was also designed with those same constraints in mind. The push service does not require dedicated thread, and we give you full control over when the notifications are processed, and you can actually combine the IO operations that we do for the push with your own IO operations. Here's simple code how you can do this. It's 3 lines of code. You set the push callback to receive the notifications. You start the push service. And then whenever it's convenient for you, whenever the device is idle or has some free cycles, you call process next push notification to receive those notifications. Here's how you can select it. Here, how you can use standard Linux select with the file descriptor for the push service to combine waiting on your own socket and our socket. The Arduino SDK offers exactly the same level of features with a small difference that the API that we offer has a higher level of abstraction because Arduino is using object-oriented language called wiring. It's still not fully object-oriented, our API, because of all the device constraints that we talked about. We are supporting currently Arduino Yun, and we are working with Arduino and Atmel to bring this to the Arduino Zero and the upcoming Wi-Fi shield from Arduino. As you can see, saving an object on Arduino is almost as easy as saving an object on embedded CSDK, except you have to write a little bit more code because we have convenience methods. Receiving push notifications follows exactly the same model. You start the push service. Whenever it's convenient for your device, for you, you check whether there is a new push available, and you process it. So James talked about restricted sessions, and I mentioned those as well. But how does a device get a restricted session? The phone creates the restricted session with the cloud. Then it uses whatever means you want, Wi-Fi, Wi-Fi Direct, Bluetooth, to send that token to the device. And then the device uses the token to create an installation and update the session. This is probably the most specific scenario for the IoT, but to showcase this scenario and also all the other possible scenarios for interaction between a phone application and a device, we have a new sample application called Any Device that you can go and download today. And you can check also our quick starts and our downloads and go build some connected toasters. Thank you. And I'll hand it off to Andrew.
Fancy. Hi, everyone. I'm Andrew. I'm a JavaScript engineer with Parse and a longtime user of React. Now, React was developed within Facebook to simplify the way that applications were developed. And in just a couple of years, it's seen adoption as a developer tool throughout the industry. Both within Facebook and without, React's actually changing the way we develop apps. And much of this is due to the fact that one of its core goals is to reduce the number of concerns that developers have to deal with. So, as a React user myself, I wanted to make sure that all these developers adopting React would be able to use parse data without having to sacrifice any of the benefits it brings or add too many layers of complexity to their apps. And that's what we're launching today, is the ability to use parse data seamlessly from any React application. React lets you build the view layer of your app. It lets you define your visual needs. Now, what does that mean exactly? Well, as a React developer, you simply express how your application should look at any point in time, and React will actually handle the changes as your application moves from one state to the next. Now, it's a fantastic concept, and we wanted to bring that to the data layer of your application. So with our new Parse plus React library, you can similarly define your data needs. If you have a component that needs access to parse data, all you need to do is attach a query directly onto it. We're co-locating the concept of requesting data with the code that's actually going to use the results. In the background, we'll handle fetching those objects, and then we'll make them available to all the relevant pieces of your application so that you can focus on what data you need rather than how it gets there. So this is the typical flow of a React application. Like any app, you're going to have some state, but with React, your state is what's used as the input for all of your rendering methods. Those rendering methods that you write, they take that state and use them to generate a virtual representation of the DOM. This is how React thinks your application should look at this point in time. It then combines that with the actual DOM as it is, as your user is seeing it, and makes sure that your user then sees the updated render. Of course, with any interactive application, you're going to have users clicking buttons, typing letters, and ultimately updating the internals of your application state. When that happens, React will re-trigger this rendering loop. It'll generate a new virtual DOM, and your user will see the updated view. We took this same exact cycle for managing view and adopted it for managing your data. Based on your app state and the code you've written, we'll build queries that we send off to Parse. We'll get some results back, and we take those objects and we merge them directly into your app state. What this does is force these two loops to combine into one larger application cycle. When those objects come back from Parse, they're probably going to trigger a re-render on the view side and show your user something about that new data. And when your user clicks that button, say, clicks next to update some view, it may change the parameters of a query and force that to fetch new data. But with both your view and your application data acting as functions of your current state, it's really easy to predict how your application will look and act at any point in time. Of course, this is only a scheme for requesting data from Parse. For modifying data, which is any real app needs, we have a Parse-specific Flux implementation. It's a React-friendly way of structuring your app. Now, Flux was actually discussed at last year's F8 conference. It's a way to build scalable React systems. The core of it is this single direction of data flow that lets you share data across many different components without having to worry about race conditions or synchronization issues. In this, components will receive immutable copies of data, and then rather than modifying it locally within the scope of the component itself, they issue a mutation message back up to the storage layer. The storage layer combines that message with the current state, creates a new object, and pushes that down to all the components that need it. This lets you update data from a single view without having to have crosstalk across many of them. Now, one of the things about Flux is that it's a concept. It's not actually a single library. And this means that developers, when they're implementing it, they can find themselves writing boilerplate for their specific data representations, or the mutations that they support, or the remote APIs that they talk with. But because we know that you're using Parse data, and you're using our Parse API, we can provide all that interface code for you. And better yet, we can actually hide most of the details behind the scenes so that the only pieces of code that you have to interact with are the ones that are specific to your library or your application. So here's how it fits into your code logically. When you're developing with Parse and React, you'll already have those SDKs in place. We're not replacing those. The Parse JavaScript SDK is for interfacing with our remote APIs and handling things like user login. The React library is there for building all of your UIs in a component way. And what Parse plus React does is it sits on top of these and provides a single developer-friendly layer that bridges all of the functionality between the two. So this is what actually lets you push Parse data to a React component or initiate a mutation from within one. With all of these Parse interactions, we've tried to make it feel like a natural extension of the React ecosystem. Rather than explicitly executing a query and waiting on a callback, you simply subscribe to a query from your component. And when the results come back, it's part of your component's natural render cycle. And when you do initiate a query, it's very much like the render cycle in that it's only a function of your current state. It's completely memoryless as to what may have come before. And when the results come back, they are as immutable, plain JavaScript objects that are really easy to handle from within React. We also followed React's example by providing all this functionality in a minimalist API. You can do a lot with very little code. All of this helps maintain the simplicity that comes with developing with React. So let's dive in further to fetching data. As I said, everything happens at the component level. You attach your query as a part of your component, and therefore you co-locate that data request with the code that's going to use it. There's no need to touch an external object. You don't need to interact with a solid object store. You don't need to handle callbacks on dispatchers. All of that we handle for you. And this mixin, the library that actually gives your component these tools, is it uses real parse queries from the JavaScript SDK. You don't need to learn another dialect or way of expressing these. We thought that worked pretty well, and so all you have to do is say, new parse query of this class name and attach conditions onto it. Another great thing is that because we're handling all these through a central channel, we only issue a single copy of a query at a time. If you have a bunch of components that are using the exact same data, they'll all sit on the same request, and whenever that request comes back with results, all those components get data. So here's what it actually looks like. This is how you'd build a standard React component. It's hard-coded, it's kind of boring, there's absolutely no parse things happening here. So what we do is we call create class. This is what's creating this component, this modular piece of our application. All this needs at the bare minimum is to require a render function. And render says, this is how I want my app to look given the current state. As you can see here, we're hard-coding an unordered list with some items. It's not the most exciting component. But what if we could pull comment objects from Parse? Well, I'll show you what that looks like. We're shifting down the render a little bit to add a couple more sections. First, we add this mixin. This is what gives us all these abilities. And then this adds a new lifecycle function, observe. Now, observe is actually part of an upcoming proposal for future React versions. And we've been working very closely with their team to start building out this functionality now. So we can build not only something that works with React today, but something that works as hopefully all React adjacent libraries will in the future. What observe does is it lets you declare your queries and attach them to a name. So in this case, we're getting a query for comment objects. This is just going to fetch all of them. There's no restraints here. If you look down in the render function now, you'll see this.data.comments. That's where we're actually referencing the results. When this component first mounts, that will be an empty array because we haven't fetched the objects yet. But when that query comes back, it'll force our component to re-render, and now we will map over every single one of those items and print out its text as one of these list items. So, as I said, you can't have any really fun dynamic app without also updating data. And these data mutations are part of this Flux single direction flow. From the component, you issue it upwards by just dispatching it. And what this does is the storage level will send that message off to the Parse API, and additionally, it will update it locally. Now, one of the coolest features that I haven't yet touched on is that we update all of these objects locally and farm them out to all of these subscriptions. So when you created that component that was subscribed to all comment objects, that's not only saying that you wanted all comment objects from the server at the time of request, it's also asking for all objects that are created or modified locally that match in the future to be pushed to that component. So if we created a new comment object, that component would be automatically updated to include it in the body. And we actually take this one step further even, and that is that when we issue a change, we can optimistically update your UI as though the server response were instantaneous. And what this does is it allows you to build a really snappy, fast UI. And then, of course, worst case scenario, if the server fails to create your object or there's some consideration that you have left out, we can roll it back easily, and you don't have to worry about handling successes and errors. So what does this look like? Well, it's pretty straightforward. It's really just one line of code. We have a mutation. In this case, it's a create mutation. We're going to create a new comment object, and we're initializing it with some text. So we specify the class name, comment, and we have some initialization data. When we dispatch that, that's what actually goes off to the Parse server, creates that object, and feeds back any changes that may have happened on a before save. And it also immediately updates all of our components locally that are subscribed to queries that match this object. With both of these tools, it's just the subscriptions really and the mutations, you can build highly dynamic applications with Parse and React. And all the things that you're used to from our JavaScript SDK, cloud functions, security tools, user management, all of this is still available to you as you normally would use it, but now we're providing you a way to fit it into a React application. And there's one last thing I want to talk about. React is a really versatile tool. It's designed for building things on the client, but you can actually render your pages on the server with React and pass them as the initial body to your client. And most recently, the React team announced React Native, which lets you build native mobile applications with React and JavaScript. And I'm really excited to announce that when React Native is launched, these tools will be compatible with it. You'll be able to use Parse, React, and JavaScript to build fully mobile native applications for any of the supported devices. That's our session today. On behalf of myself, my co-presenters, and really the entire Parse team, I want to thank you for coming today to hear about all the things we've been cooking up and everything that we're launching. Now, I also want to mention that we have a booth in the developer garage for the next 2 days where we have team members ready to answer any questions you may have, either about the products you've seen today, because I know there's a lot, or any of our other offerings. Now, actually, we have about 10 minutes for a Q&A, so if you guys want to come on up, and I think we can pass mics. Over here. Yeah.
Yes, I'm Saurabh Jain from SKJ Technologies. So we are using Parse, but as a developer, I am a little apprehensive. Like, what is the roadmap if we want to make a big app, a very big, very complex app? So basically, what I would require would be like going ahead. How do you see Parse? Like currently, if we are using AWS, how do you see Parse? Is it a complementary thing or is it a competing thing, or like? So can we build an app entirely out of Parse? Those kind of, I have those kind of things in my mind. So can you give some thoughts on that?
Yeah, so Parse can be used in many different ways. We have very large apps that are using us for the entire backend for the app, and you can certainly make basically, for example, AnyPic, which is our kind of example photo sharing app. That's using push notifications, using Parse Core for data. All that can work for your mobile app. That being said, a lot of people also use this in kind of hybrid environments. What we're launched today with Cloud Code webhooks will really help with that. So there are people using also the REST API to grab data based on things that happen in your application. So it really depends on what you're building. And I'm happy to follow up with you afterwards to chat more about that.
Hey, so we use Parse in one of our mobile apps, and something that we've really needed to do with respect to our parse queries, and I've noticed that a lot of people have asked about it, but it seems that nobody is, or it has been part of the roadmap, and I just wanted to get some insight onto whether it would be. And it would be to do queries with group by distinct, so that we could get distinct columns back from our queries. Is there any time that may happen instead of us kind of rolling our own solution on the client?
Yeah, so we don't have that capability right now.
Right.
Yeah, unfortunately, I can't share anything with that. Yeah.
I thought I'd try.
Hi, my name is Marcel. I would like to thank Parse because it solved all my mobile backend problems. I handled 2 million users just with Parse. So
congrats.
Yeah. And one thing that I use a lot is the push notifications. I would like to know if there is a plan to have like a localized push notification, because today I just when the person registers in a badge, I capture the language, and for that language I send an English push notification, for other in Portuguese. There will be like a feature with automatic language specifically directed push notification.
Yeah, that's a good request, and yeah, we've also heard many other folks having that. So are you basically sending N push notifications, one for each language that you're sending. Okay. Nothing I can talk about, but that seems like a pretty useful feedback. And I'll take that back to the team.
My apps use a lot of relationships, and maybe there's a way to do this, and I'm just not aware of it. But can I just create a bunch of objects on the fly and then push one update and then get all the unique IDs back in that one response? So for instance, a person and an occupation. So I add a new occupation and I add a new person and I save the person. Is there a way to just say, here's that person, now can you also give me back the occupation ID that I just created so I can get the object ID and stuff like that? In a one call, not without having to say, save occupation, get the ID, create a new person, add the relation. Is there any sort of roadmap?
I would think the easiest way to sort of make that a single call would be to actually make it a cloud function, and you'd pass the relevant data into the function to create that person, that occupation, whatever you need to do. And then that object, or that cloud function will actually do the saves necessary. But from the perspective of your application, it will be a single call out and one response back.
And that's the cloud code that you guys run, right? Not the one that I have to run?
Well, now you can do it for both.
Either way.
Okay, yeah. Cool. Awesome, thanks.
Yeah, so that's actually an interesting point about architecture. There are a lot of folks who use just our client SDKs and do kind of multiple calls on the client. And then there are a lot of our customers that use solely cloud code and make a lot. It's more traditional kind of server where you have complicated backend code, but you only have to make one call. So both of these are possible, and we've seen customers maybe slowly migrate from one to the other. There's pros and cons for doing both, so it's really up to you.